Good morning, everybody. Good morning, Bones. It's time to start a new topic. New topic is called meteorology. One of the coolest topics that we're going to learn all year because it affects us every single day of our lives. Okay? What's meteorology really mean? Meteorology really means we are going to be studying the weather. Okay? And the weather is something that we pay attention to every single day. Okay, we got to know how to get ready for the day. We got to know what type of clothes to put on, whether we need a raincoat, whether we need an umbrella, whether we need earmuffs, whether we need gloves, t-shirt and shorts. The weather affects our lives every single day. All right, and that's what we're going to take a look at. Why does the weather happen? How does it happen? What kind of conditions make it cold or warm and all this different kind of stuff? So let's go. All right, so meteorology, the study of the atmosphere, or also known as the weather. And you can see a nice picture of a pretty cool looking hurricane right here and a little tornado over here. All right, pretty cool looking. That's some satellite imagery of different kinds of weather as they pass through the earth. Satellite image of the hurricane, and this is probably just somebody taking a cool picture of a tornado that I liked. All right, you like it, Bones? All right, let's go. Okay, before we can start taking a look at what actually causes the weather, we have to take a look at what the weather is within, okay? And the weather happens in our atmosphere, okay? Now, our atmosphere is the bubble of air or the bubble of mixed gases that we live in, okay? It surrounds the earth. Now, usually when we talk about air and what we need from the air in order to stay alive, everybody's first answer is always, what, Bones? What's in the air that keeps us alive? Oxygen. That's right. Oxygen is part of the air, but oxygen isn't as much in the air as you think, okay? 21% of the air that you breathe is oxygen. 78% of the air is nitrogen, okay? So there's actually more nitrogen in the atmosphere that we walk through and that we can feel. You wave your hands like this so you can feel the air, okay? And you're breathing it in, breathing it out. You're actually breathing in 78% nitrogen, okay? 21% oxygen, and 1% other stuff, water vapor. Okay, there's water in the air. You can't see it. It's a gas. There's ozone, which is a form of oxygen, and there's carbon dioxide in the air. Okay, so you breathe all of that in and out every single day, and it's totally fine. Now, we also find other things in the air that we call aerosols. Aerosols are like little suspended liquids or solids in the air. Sometimes you can see them, sometimes you don't. For instance, dust is in the air. You know, if you've ever sat down on a dusty couch and if the sun's coming through the window quite right, you can see the dust pop up. Salt crystals are in the air if you've ever gone to the beach. And you can see the salt crystals kind of floating around at the beach. Your skin starts to taste salty from the salt water. Pollen, okay, that yellow stuff that comes from flowers. Soot is in the air, all right? Soot, that's the stuff, that black stuff that's left over after a campfire or after a fire. Ice crystals are in the air, and water droplets are in the air. So aerosols are just any kind of solid or liquid that is also mixed in with the air, okay? It's not just gases. There's other stuff in there. Now, most of the air that we breathe in, that we live in, are gases within the first 5 kilometers of the Earth's crust, okay? So it's pressed into a thin kind of shell of air going around the Earth's crust. And the atmosphere is actually very young and fragile. Okay, what we do as human beings, as a species here on Earth, affects the atmosphere and how it's changing. And the atmosphere is always changing, and it's changed over the few millions of years, and has really rapidly started to change most recently in the last few hundred years. So our atmosphere is only about 800 million years old. Now, I say that's young. Okay, that's young when you compare it to how old the Earth is. The Earth is 4.6 billion years old. So the atmosphere has not been around as long as the Earth, okay? It's actually quite young when you compare it to the Earth. So the same kinds of organisms that are living today on Earth weren't able to live when the Earth was first came to be. And we'll talk more about that later. So our atmosphere, important things to remember, is made up of 78% nitrogen, 21% oxygen, and 1% other stuff. But there's not just gases, it's also have this stuff called aerosols mixed in with it. So let's take a look at what those aerosols and stuff look like. So here we go. Remember this chart. This chart's very important. It's going to come up again, and it's an easy way to remember what makes up our air, okay, or our atmosphere, I should say. 78% nitrogen, nice little pie chart, 21% oxygen, and a little bit of 1% everything else, okay? Now, here's a nice satellite image of some aerosols that you may see. You've got clouds made up of water droplets and water crystals, okay? You've got some sand flying around in the atmosphere that you may be able to see, you may not be able to see. But again, so we've got air, which is a mixture of gases, or the atmosphere, which is a mixture of gases. And then we have these things called aerosols mixed in with it. Okay, these aerosols are going to be important later on in the unit when we see how clouds form, because water actually sticks to these aerosols in order to make clouds. Did you know that, Bones? Yeah, that's right. Clouds are kind of like a sponge. You'll see when the sponge gets too heavy or too full, the water falls out of it, and we get rain. Can't wait. Okay, now our atmosphere, okay, is split up into layers. All right, and the layers, you have to remember the order of the layers, and each layer has certain characteristics within it. So the layer that we live in, the one that is closest to us, that we breathe the air in it, is called the troposphere. Okay, that's that layer that is closest to the Earth. You can see it down here. All right, I like to think about learning the layers of the atmosphere as a stack of pancakes. Okay, if you have a stack of pancakes and each pancake is a little different, okay, it's really easy to just picture in your mind what the layers of the atmosphere are made up of and their characteristics in it. All right, so it's my own theory that I came up with. I relate everything to food. Bones, you know that. You actually look like you could use some pancakes, Bones. You're looking a little thin today. So we're going to learn this as like a stack of pancakes. So our lowest layer of the atmosphere is called the troposphere. Our second layer, okay, is called the stratosphere. And an easy way to remember the stratosphere is the second layer of the atmosphere is because they both start with the letter S. Okay, so that's a nice little trick to try to remember that. Then we have the mesosphere. The mesosphere is the middle layer, okay, of the atmosphere. I consider it the middle layer of the atmosphere. And it starts with the letter M. So a little trick to try to remember it. And then we have the thermosphere. Okay, the thermosphere is sometimes called the exosphere. And that's the layer that's farthest away from the Earth, all right? So we're going to focus mainly what we study in the troposphere because that's where we live. But you need to know the different layers of the atmosphere. And please understand the layers of the atmosphere stack up upon each other like a stack of pancakes, which we're going to talk about. So what do we find in each atmosphere? They have certain conditions in each one, and that's what you need to know. So we'll start with the troposphere. The troposphere is the lowest layer. Okay, the troposphere is the layer of the atmosphere that is closest to the Earth. This is the most dense layer of the Earth. Now, what does it mean if it's dense? Dense means that the air molecules are really squished together. All right, so let's think about this. If we had a stack of pancakes on a plate, and the plate is the Earth, okay, we have a stack of pancakes. We've got 4 pancakes stacked on top of each other. Which pancake is the pancake that is the most squished? Which one is going to be the most dense? Which one is going to be squished by the other pancakes? Bones? It's the bottom layer. It's the bottom pancake. The bottom pancake, just like the bottom layer of our atmosphere, is the most dense. It's the most squished. So that's one way to remember that this is where most of the atmosphere, most of the air of the atmosphere is compressed into. Okay, it contains most of the atmospheric gases, which is good because we need that in order to breathe. Okay, we need those dense gases in order to fill our lungs with oxygen. Okay, this also contains most of the moisture of our atmosphere, and that's again good because we need water. We're living things. We need water. We need to stay hydrated. Okay, so that water comes from evaporation from oceans and lakes and water vapor and rain coming back down. So most of the water and moisture that we find happen in the bottom layer, in our troposphere, the bottom pancake. And another interesting thing about this layer of the atmosphere is as we move up through it, as we go up in elevation, the temperature actually decreases. Okay? So as we go up in the air, it gets colder. It gets colder. And think about it. If we start climbing mountains, and so we're going away from the Earth's surface, and we're going higher and higher up into the air, what do we find on top of mountains, Bones? I know it's cold up there, and you get especially chilly. We find snow, okay? That's because the temperature is getting colder as we move away from the Earth. So I like to think about it as having a campfire going, or a bonfire going, or a fire pit going. The closer you are to the fire, the warmer you are, okay? As you walk away from that campfire, it gets colder. So the Earth is kind of like a campfire, okay? There's heat in it. As you move farther away from the Earth in the troposphere, it gets colder as you move up through the sky, okay? So that's our bottom pancake. Our bottom pancake is very dense. It contains most of the gases for us to be able to breathe, which is good, and most of the moisture to help us stay hydrated. As we move away from the Earth up through the troposphere, the temperature goes down, okay? Remember, snow on top of mountains. Then we pass into the second layer of the atmosphere. That's known as the stratosphere. This is our second pancake, okay? Here, okay, the air is very dry. Now we are above the clouds, okay? We're just about above the clouds is kind of where the stratosphere starts, okay? There is no weather up there. If you've ever been in a plane, okay, and you go above the clouds, even if it's raining below you, the clouds below you, it's still pretty nice up there. It's actually really nice weather. The air is dry. Clouds are very rare, so you really don't see them, and there's no weather, all right? Now, because there's really nothing there, okay, and this is where we find our ozone layer. Now, because we have the ozone layer protects us from harmful radiation from the sun. Okay, it absorbs the ultraviolet radiation from the sun to prevent the Earth from overheating. Now, because the ozone layer is absorbing sunlight, the temperature in the stratosphere starts to go back up. Weird, but it's true. So as we move up through our two pancakes, in the first pancake, the troposphere, the temperature decreases, goes down, because we're moving away from our campfire. But in the second layer of the atmosphere, our second pancake, the temperature starts to go back up because we have the ozone layer there, and the ozone layer absorbs ultraviolet radiation from the sun. So that's our first two pancakes, the troposphere, and on top of the troposphere, we have stacked the stratosphere, okay, where the ozone layer is located. As we move up to our third layer of the atmosphere, that's what's known as the mesosphere. There's not much happening in the mesosphere. This is like the beginning part of outer space. We've gotten through the ozone layer, okay? We're not quite in real far away outer space yet. So it's known as the mesosphere. There's no water vapor now, okay? There's no remnants of water whatsoever. There's no aerosol, so there's no dust, so it's extremely clean. And since there's not really anything there, the temperature starts to decrease again. The only reason the temperature increased in the stratosphere is because the ozone layer was there and it was absorbing ultraviolet radiation. Now in the mesosphere, there's nothing there. If there's nothing there, the temperature goes back down, okay? So that's our third pancake. Again, so we have the mesosphere, okay? Below that is the stratosphere, below that is the troposphere. So we've got a stack of pancakes that we're building. Finally, our top pancake. Our top pancake is the fluffiest pancake, all right? Because we don't have any other pancakes stacked on top of it. So everything is really spread out in the top pancake, which we call the thermosphere. Sometimes you'll see it noted as the exosphere. Now, there's some pretty cool stuff that happens in the thermosphere because it's really far in outer space. First of all, we get these things called northern lights, okay, also known as the aurora borealis. You can see pictures of it right here. They are absolutely beautiful, okay? We cannot see them here from Long Island, but the farther north you go, all right, if you get up into Canada, you can see them from Minnesota, you can see them from Alaska. Near the northern border of the United States and in Canada, you can see them a lot more often. These are charged ions. These ions absorb solar radiation and they cause the sky and the outer space to start to glow. And it glows greens and purples and pinks, and it's really cool. It's like a rainbow in the sky at night. It looks really awesome if you've ever seen them before, okay? Also known, the aurora borealis, also known as the northern lights, charged ions that we find in the thermosphere, our top pancake. This is also the area where meteors disintegrate, okay? Meteors fly through the atmosphere, fly through outer space, and meteors can actually hit into planets. And most of meteors, though, don't even hit the Earth or other planets because they burn up, especially in our thermosphere, and they just disintegrate. Now, because we have meteors here, and because we have the aurora borealis, also known as the northern lights, the temperature starts to go back up again because there is something there to warm up, okay? So our layers of the atmosphere are like a stack of pancakes. We've got four main layers that you have to remember, all right? Troposphere, stratosphere, mesosphere, thermosphere. Here's some more pictures of those northern lights that I was talking about that just absolutely look fantastic. Okay. You can see them more often certain times of the year, and you have to be at a higher latitude than we are here on Long Island to really see them pronounced. But look, you got pretty green colors and red colors. They're just really cool to see. If you ever have an opportunity to go out and see the northern lights, the aurora borealis, if you are farther north in the country, I highly recommend doing it. It's very cool. Bones and I have both seen them. Very awesome. So let's review. We've got our 4 layers of the atmosphere that we're going to remember like a stack of pancakes. Okay. Our troposphere is our bottom layer. It is our most dense layer because it is the bottom pancake. Everything is squished more than the other layers. This is where we find our weather. This is where we find our most dense gases. Okay. Very important. And this is where we find the most moisture. All important things for us to be able to live. So we live within the troposphere. As we move away from and the temperature, as we move up through the troposphere, remember it goes down because we're walking away from the campfire. When we hit the stratosphere, that's where the ozone layer is. Okay, we're above the clouds now. The stratosphere, the temperature starts to go back up because the ozone layer is there. Then we hit the mesosphere. Not much happens in the mesosphere. It's very clean. It's kind of that transition space between our ozone layer and the really far outer space until we finally get into the thermosphere, where we find the aurora borealis, also known as the northern lights. And this is where our satellites go around the Earth, meteors disintegrate, and that kind of stuff happens. So this is like the beginning parts of outer space now, all right? So we need to know the 4 layers of the atmosphere, guys, all right? And just remember it like a stack of pancakes, and you shouldn't have a problem. Till next time.